Hello everybody. This video accompanies notebook 4 of the series Exploratory Computing with Python. My name is Mark Bakker and I work at the Delft University of Technology. Today's topic is functions. Functions are pieces of code for a certain task. You group them together in a function so you can test them separately and use them later. We've already used quite a few functions, for example the plot function or the function to compute a cosine. Today we're going to write our own functions. We start again by importing NumPy as NP, by importing the plotting part of matplotlib as PLT, and by telling IPython that all matplotlib figures should be inline. We're going to start by writing a function for this polynomial. Y is ax squared plus bx plus c. Let me show you how to do that. Any function should start with the three letters DEF for definition. That's what Python calls a function. And then you have to make up a name for the function. We can call it testfunc, for example. Then you need to open a parenthesis, and you have to tell it what arguments you want to pass to the function. Even if you don't want to pass any arguments, you have to open that parenthesis and then close it again with nothing. But we are going to pass it something. We're going to pass it the variable x. Then we close the parenthesis, and then we need a colon. We hit enter, and just like for a for loop or an if loop, you see that IPython indents for you. Any code I write here is inside the function. So I'm going to tell a is 1, b is 2, 3 is equal to c is equal to 3, and y is equal to a times x squared plus b times x plus c. And then I'm telling you telling the function on its last line, return y. And I hit shift enter. Now this function exists and I can call it. I can call testfunc, open the parenthesis, and see it even tells me testfunc should pass x, so it knows this function. It does the same thing as it does for any function. It opens up this extra help, and you can tell it, I want to calculate it at x is equal to 2, hit shift enter, and you see the value is 11. I can even store it in something. I can say z is equal to testfunc2, then the value it's returned, that inside the function is called y, but whatever it's called inside the function doesn't really matter. I'm simply telling it to assign it to the variable z. And I can now say print. I should be able to type print z, and it's 11. Notice that outside that testfunc, it doesn't know what a, b, c, and y are. They are defined inside the function, and the only thing it knows outside the function is whatever is returned, and it doesn't even know the name of whatever is returned. It only knows the value. So I can say here print a, and I will get an error. A is not defined. It's only defined inside the function. I can also not print y. Y is also not defined, only in the function. Return y only means return the value of y, and whatever I say here, variable I define here, is where it is stored in. All right. Now, when we set testfunc, when we call testfunc, and we open the parenthesis, you saw it gives some help here. And it even says no docstring. This is not much help. If you want to have more help, you can simply type it inside the function. So I'm going back here. You need triple quotes at the top of the function. And you say, oh, here is some additional explanation. We don't have we don't have much explanation here, but we can add it. We hit shift enter again. So we have redefined our test function now. And if we now type testfunc, open the parenthesis, you're going to get this nice help. And here we see, here's all the help that we've added here in this triple quote statement, which can be multiple lines if you wish. In the testfunc we've written so far, we've defined a, b, and c inside the function. But we can also pass it towards the function. So let's go back here and say we'll pass it a, b, and c. So we don't have to define them inside anymore. We hit Shift Enter, so it's redefined now. If I now try to run this code cell 8, we're going to get an error. Because it says, well, it takes exactly 4 arguments and we've only given it 1, right? We've given it 2, which is the value of x. So we also have to tell it the value of a, the value of b, and the value of c. We hit Shift Enter again. Ooh, not value of c, should be number 3, and that works fine. But even nicer to give these a, b, and c values default values. So we can do that by doing it this way. We add here in the function definition a is equal to 1, b is equal to 2, and c is equal to 3. We hit Shift Enter. Now if we run this code cell, it still works, but we could also not define a, b, and c, and we still get the right number. Or we could define a and not the other one, say a is equal to 4, and run it. Or we can only define b and run it. Or b and c. Any combination of these keyword arguments you can decide on yourself, as long as you make sure that the regular arguments, which don't have any default values, are defined first. They all have to be defined. In this case, there's 1, so you have to give the value of x. The keyword arguments you can give if you want to. If you don't want to, it uses the default value. If you specify a value, it will use that one. We can also use our test function in this case by calling it with an array. We could say, for example, x is np.linspace from -2 to 2 with 100 points. And I'm saying y is equal to test func x using the default values of a, b, and c, and then say plot x versus y, plt.plot x versus y. I hit Shift Enter, and here's our figure of our parabola. Now, this is nice that you can call this function with an array, but that's not always possible. For example, we could, when is it not possible is when there is an if statement in your function. We could add an if statement to this function. We could say, for example, if x is smaller than 0, then I'm going to print y is equal to a times x squared only, and if x is larger than 0, I'm going to colon elif, maybe just else, right? Then it is larger than 0, else y is equal to a times x squared plus b times x plus c. Shift Enter. If I now call this function with a number of x's from -2 to 2, and I hit Shift Enter, it comes back with an error message, and it says, ooh, the truth value of an array with more than one element is ambiguous, right? So if x is smaller than 0, I should do this. Python doesn't know how to do that because x has negative values and positive values. So if I say if x is smaller than 0, what should it do? It doesn't know what to do. We could change the function by including syntax that takes care of that, or we could do something very easy. We can make a vectorized function of this function. That works as follows. I'm defining a new function, test func vectorized, and it's a vectorized function of test func. And I make that by calling the function np.vectorize test func. So this np.vectorize function takes this test func function as input. It returns a function. It doesn't return a variable, it returns a function. And that function I'm going to call test func vec. Now, if I use that new function, the test func vec function, on this array of x values from -2 to 2, Python will call this test func function for every x value separately. It's not specifically fast doing that, although plenty fast on this computer. And in that way, it avoids the problem where it says if x is smaller than 0, it will work just fine because it will call that function with every value of the array x separately. So if I hit now Shift Enter, it works just fine. And you see when x is smaller than 0, it only plots the function, what did we define, a times x squared. And if x is larger than 0, it takes the full parabola ax squared plus bx plus c. Now let's go back to a problem we tried to solve last week. We had a little text on the physicist Euler, and we wanted to count the number of letters in that text. We did that by writing some code, but we could easily implement that code in a function, and that would be very useful because we could use that function wherever we want. We make a new function, def count letters. What do we need? We need as input arguments a text for which we want to count letters and a letter that we are interested in. How does that work again? We count, so we have a counter that we set to 0, and we say for I in range the length of the text. We go through all the letters in the text and we say if the text I, so the ith letter in the text, is equal to the letter we have, then colon, then the count plus equals 1. And then at the end of the function, we return the count. Now this is going to work, I think, except for that we still have to decide on this lowercase or uppercase thing. We want to count both the lowercase and the uppercase. So why don't we make this letter in the text lower by saying the dot, by adding the dot lower function, and also the letter we provide, let's also make that lower. So even if you say, well, let's try to find all capitals, if H's will just find all H's. That's what our function is doing. And we say we count all letters is our explanation. Either upper or lower case. We hit Shift Enter. Oh, and we get a syntax error. This is actually a very common syntax error. If you compare two things and to try to decide if things are equal, it should say this should equal that with two equal signs. One equal sign is assignment. Then you say like this is going to be equal to that. If you want to compare, then you have to have two equal signs. There we go. So we can do this now. We say count letters. We give it as input argument the text that we defined right here. Get rid of this box. The text, and we want to find the letter H. We hit enter, and you see it finds 18 values of H, or 80 times the letter H. Now if we want to count all the letters of the alphabet, each one at a time, we can put this function in a loop. We first define the alphabet. Alphabet is all the letters. Notice we don't have to make that into a list or anything. We can simply access every letter in the alphabet by saying alphabet I, or 0, is the letter A, and number 10, I think, is the letter J, K even. Oh, because it's the 11th letter, which has index number 10. And we can loop through that. So we say for I in range length of alphabet. We say the C is equal to count letters, the text, and then the letter, which is alphabet number I. And we print the letter alphabet plus alphabet I appears plus plus the string, the number C converted to a string, plus times. And there you see, oh, I have a nice space after appears would be good. The letter A appears 38 times, the letter B 0, C 18, and so on, and H was 18 times. And you see, we nicely make use of the function count letters. We loop through all the letters of the alphabet. We call the count letters function, which returns the number of times alphabet I, the letter alphabet I, appears in the text, and we print that to the screen. That's all I had for you today. I hope to see you next time.